Hello everyone, welcome to Online Linux Mindtree training. As we are in the Mindtree coding section, we have three sections, that is implementation, DS Algo and advanced DS Algo. Today I am going to discuss a brief info about DS Algo and what kind of questions you will get, and also a solving of one coding question. Coming to the DS Algo section, a candidate must have a basic idea about all the sorting methods, the searching methods, and the basic info about the data structures. Okay, let's discuss about the searching first. You should have a basic knowledge about two kind of searches, that is, one is linear search and second one is binary search. In the linear search, those who don't know, we do this operation to search an element in any kind of collection, that can be a list, can be an array, or can be a set, and anything. So to search that, the linear method says that we need to iterate it from left to right, or from start to stop, or from the beginning to the end, and we need to find out each and every character or the data, and whichever is matching the searched value, matching as per the search value, we need to return it, and we need to say that this element is present in the array or collection. That's how linear search works. Coming to the binary search, and in the binary search there is always a predefined condition that if you want to implement the binary search, the data should be in a sorted manner. And after it's sorted, we need to implement the binary search. And actually how the binary search will work is, it will divide the complete collection into two parts and check whether the mid value is equal to the search value or not. If it's equal to the search value, then it will just say that it is present in the list and this is the index position, it will return. If it's not, it will compare whether the search value is less than mid value or search value is greater than mid value. If the search value is less than mid value, then it means that the search value will be staying left side to the mid value, that is to the previous of mid element. And if this the search element is greater than the mid value, then it means that the element lies the right side to the mid value. So based on that, algorithm will again work, and it will divide the right side. If suppose it take the right side, again it will divide to the mid value, and again it will compare. If it's then it will return, otherwise it will check the left and right, which is the conditions side, and again it will divide, and finally it will come to an output where whether the element is present in the list or the collection or not. And for this, it will take order of n time complexity, that is linear search. For binary search, it will take order of log n. This is about the two sorting methods. Coming to the two searching methods. Coming to the sorting methods here, we have 5 basic sorting methods which everyone should be aware of. One is bubble sort. Next is insertion. Third one is selection. Fourth one is quick sort, and fifth one is merge sort. These mentioned should that everyone should be aware about these 5 sorting algorithms, and basically these 3 will take worst case as an order of n square time complexity, and these 2 will take n log n as the time complexity in the worst case. And how exactly bubble sort will work is, it will compare the adjacent elements, and if it's greater than the previous element, then it will just swap the data. This is how it will it will swap each and every time in each iteration, and it will finally ordered list will be generated in the bubble sort. Coming to the insertion sort, at every insertion it will check whether the position is correct or not, and it will compare it to the previous elements, the position of the insertion is correct or not, and if it's not, then it will just shift the elements towards right side or left side as according to order the data. Coming to the selection sort, this is insertion. Coming to the selection sort, it will select the index, and it will compare on all the elements. Wherever the minimum element is found, it will swap the minimum element with the current index. Same way it will swap, it will keep on swapping and swapping. At last we will have the ordered output. And coming to the quick sort, in quick sort we will be the main role is of pivot. We will be choosing a variable pivot which will be pointing to a data, and based on that pivot we will be traversing from left and also from right to check if it's any element greater than pivot exists to the right, and element less than pivot exists from the left when we traverse from the right side. And at any condition when these two satisfied, then we will replace the pivot with the right. Then the same way this process repeats again, and finally we will arrive at the ordered output. Again, coming to the merge sort. Merge sort actually divides the complete list of array into two parts each time. Suppose this has 1 2 3 2 1 4. So the 3 2 1 4 is divided into two parts here, and even this will be divided into again 3 and 2, and this will be divided into again 1 and 4. Now the merging process will take place here. I'll write it here. Then in 3 2 1 4, suppose this is the dash here, then 3 2 1 4 it will compare and merge here, which is the smaller one, 2 3, 2 is the smaller, and next 3 should come. Same way here, 1 is smaller and 4 should come, and after merging this one it will compare 2 1. Yes, 1 is smaller, so 1 will come. Next 2 3 4 2, next 3, next 4. This will sort the complete data. This is about the sorting algorithm, and it's very important to know about the 2 searching algorithm and the 5 sorting algorithm. It will be important for this drive and also for all the companies as well. And coming to the data structures, the basic data structures being asked in Mindtree, like strings, arrays and all. Not much about the linked list, hash maps or any kind of graphs and all, so just focus on that. So for now let's work on the bubble sort algorithm. We'll code the bubble sort algorithm now in Java. I'm taking a data. Let's suppose it is 5 3 1 2 4. This is the data as an array, and I'm iterating it. Int I equals 0, I less than data dot length minus 1. This is done because we will be using a j variable also, and using the j variable we will be using a j plus 1 condition, and if we are using that length, then for the j plus 1 it will come as length plus 1, then it will exceed the array and it will throw an exception. For to handle that we are just limiting up to minus 1 here, and we use a j also, j less than data dot length minus 1 minus I. This is done because each time in the iteration of bubble sort, the last element will be sorted. It means the last element will be the biggest element from the whole array. So each time the last element will be sorted, so we need to neglect this position in order to save the time. For that I'm also removing the minus I, so that we will not consider these last ones while traversing the list. Okay, so the iteration for loops are done. Now we'll use the condition if data of j greater than data of j plus 1. If it's greater, which means the previous element is greater than the right side element. That should not happen if we are not arranging it in a ascending order. From that we need to swap it. I'm using a temporary variable storing the data of j data, and again I'm storing the data of j plus 1 in data of j. So this the right side value is been copied to the left side value, but we didn't change the right side value yet. The right side will be copied from the temp. This is done. So let's, for printing it, we again need a for loop. I'm using a for each loop this time. Int d data. system dot out d. Let's see the output. Yeah, you can see I gave the input as 5 3 1 2 4 and we got the output in an order. So this is how we need to implement a bubble sort. This way we need to learn all the sorting algorithms and the both searching algorithms, etc. And everyone must and should have the knowledge about what is an array and how to create an array and how to handle the strings, how to manipulate the strings and use reusability of functions. Each and every knowledge of the basic knowledge of these are required to attempt this section. Let's solve the previous implementation questions that were asked in Mindtree. Coming to the first question, reverse words in a string. Reverse words in a string. This means if we take the example like online learning Mindtree. So we have 3 words here and we need to reverse the words in a string. We need to reverse the string in such a way that only the words will be reversed, not the complete string. Not like that we need to reverse the complete string and we need to traverse everything from E, 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 R, T, D, N, I, M, I and so on like that. We need to reverse each and every word. So the output should be like, we need to reverse this word, it should be E, N, I, L, N, O, and same here G, N, I, N, R, A, E, L, and here E, E, R, T, D, N, I, M. So this way the output should come. This is one of the common questions that's being asked in the Mindtree. Let's try to code this in Java. Let's take a string online learning Mindtree. Okay, let's convert this string and to a string array by splitting the string into the words. Okay, here is string, and for that we have the method called split, and we want to split the string based on spaces. Then so after this the individual words online learning and Mindtree will be stored as a string array in the words here. Now let's create a variable result, and now let's use the for each loop words, for each loop for words to iterate the words in this, so that I can take each and every word at a time and reverse that word and add that to the res variable and print it in the console. Okay, so we are iterating here, and let's suppose for reversing we are using the string builder here. String builder equal to new string builder. String builder gives a default reverse method. By using that we can reverse any string. So for that I am creating a string builder object which take the string parameter, that is w here, because I am using the w for taking the individual words from each sentence. So as per this, the first word will be online here, so the online will come here in the w place, and online will be stored and it will be stored in the string builder variable here, and I am reversing it. That's it. Then I am adding that to res plus equal to string builder plus I want to add a space. Yeah, and at last I want to print the result. Let's see the output. You can see the complete words are being reversed, that is online learning Mindtree. So this is how this question can be solved. Let's move to the next question. Capitalize each one in string. So if we take this one, which means that we'll take this example only, online learning Mindtree, then the output should be like we need to capitalize each word, then the starting character should be capitalized. Online learning Mindtree. The output should be displayed like this. So further, let's code this out. I'm commenting this. Okay, let's remove this. So to avoid confusion, I'm taking a string input here, that is a string value, online learning Mindtree. We need to capitalize each word in a string. Okay, let's use the same technique. Let's declare a string array which will contain some words, and we need to split this based on spaces, so that it will store the individual words in the word array. And we'll also have the same res result variable to store the result, and I'm using the for each variable again, string word words. And okay, let's suppose we take the first character as first with the variable first. So w dot substring of 0, 1. Those of you don't know what is the substring function does. The substring function returns a substring of a string. Suppose online is the example 0, 1, 2, 3, 4, 5. The length is 6 and the index start from 0 and end at 5. So if I want the substring, and if I get the input like substring of 0, 4, that means it will take up to 0, 1, 2, 3. It will not take the last value. So 0, 1, 2, 3 means ONLI. So this will be the output for sub 0 of 0, 4. And we are here using 0, 1. That means 0, 1 means it will not consider the 1. So it will just consider the 0. 0 means the first character. So by doing this, we will get the first character that need to be capitalized here, and we will get the remaining one. Remaining one will be w dot substring of 1, and here 1 indicates if you are using a single value inside the substring, it means this is the starting value and the end value is the length of the substring. That's it. And we will be adding this to the result. First dot to uppercase, that is we want to capitalize, and we just need to add the remaining, then spaces, then we'll print the output here, print dot println res. You can see I gave the input as like this, and you can see that the complete words are getting capitalized here, the first character. And in case if any test case didn't pass at the time of examination, that may be because of the extra space that's been added to the last word. To remove that, you can use a function trim here, which will remove the extra spaces at both the ends, so that your test case can be passed. So that is about the second question. Let's move on to the last question. Toggle each word in string. Coming to the toggle, let's suppose we'll take a small example, ONLINE. From this string, we know that L and N are the capital letters and the rest are small letters. So when we do the toggle, then the output should be like ONL, small l, capital I, and small n, capital A. So it's basically like, if it's a small, if it's a lowercase, we need to convert to an uppercase. If it's uppercase, we need to convert to lowercase. This is called toggle problem, and this is also the most common problem asked in many of the examinations. Let's code this. Let's take an input like online, yeah, and let's create a function here, public static, we should return a char, and the function name should be toggle string. and I'm taking input as char, that is str, and I want to toggle the string, the characters that's present in this array. So for that I'm using the for loop, int I equal to 0, I less than str dot length. Okay, and I'm checking whether the character that I'm traversing, whether it's uppercase or a lowercase. For that I'm using the condition greater than or equal to a and less than or equal to z, which means the character that we are traversing is laying under capital letter category. So if this condition satisfies, then we need to make this character to lowercase. For that we will be using a special condition, that is str plus small a minus capital A and semicolon. This may give error because we want to convert this to char here. Yeah, the error is gone. Same way we need to implement this for small case. If it's a small case, we need to convert into the capital case. So if it's a small case, then small a to small z and capital A minus small a. This way the str is done and we need to return the str here. So we have the function that can toggle the complete string. So let's take a char variable and call this toggle string and pass our str.toChar array that will convert the string to the toggle case. And we have the toggle. Let's print the toggle here, string.out.println. We need to print in a form of string, so I'm using this string.value of method and keeping the tog here. Let's try to run this. Yeah, you can see I gave the input as O and LINE, it came here. Let's suppose one more like AJ AY. Okay, the small this need to be converted in the caps and the other three need to be converted in the lowercase. Let's see. Yeah, it's working fine. So this is about the implementation type of questions that has been asked in the Mindtree coding section. And as I said, you need to be having thorough knowledge and about arrays, strings and functions to code in this level. All the best. Thank you.